In this video, we will package a Shiny app as a standalone utility. That means that we will have a single file, app.r, that contains our user interface as well as the server code, and we will run that with the R script executable. By packaging it with Guix, we'll be able to make it a dependency of our application LIMS nucleus. And because it is assigned a hash code, we'll be able to track it with the Guix generations mechanism. Let's look at the visualization that we will convert to an app and package. Here we are looking at LIMS nucleus running on Amazon Web Services. If we navigate into Project 1, scroll down and look at Assay Run 1, we see all of the samples sorted by response intensity, color-coded by sample type with a threshold that identifies a number of hits. We can replot using different criteria and obtain different number of hits. If we're happy with this hit number, we can view the hits and make a hit list. Here is that visualization as rendered by Shiny. This is being hosted on shinyapps.io. So again, you can see the data points are sorted by response, color-coded by sample type, and a threshold is set that allows us to identify hits, and we can modulate that threshold to change the number of hits. When we're happy with the hit count, we can create a hit list. What I just showed you was a Shiny app running on shinyapps.io. I was viewing it with my web browser, and it was pulling data from a PostgreSQL database hosted on elephantsql.com. ElephantsQL is a cloud provider that specializes in PostgreSQL. The first visualization I showed you was LIMS nucleus running on Amazon Web Services. The PostgreSQL database was also running on the same EC2 instance. It contained the same data as was in the ElephantsQL database. This is the example data that comes preloaded in LIMS nucleus. It doesn't matter where that database is located. It could be your local machine, it could be a cloud provider, it could be a cluster in your organization. As long as you have a valid connection string, you can work with it. What we'll do now is we will hack that app on my local computer to figure out how we need to write the packaging recipe to package the app. Once we think we have it working, I'll transfer it to Amazon Web Services. The reason I do that is because my local computer is cluttered with different software, and I maybe don't realize I have installed something that is contributing to the functioning of the app. By moving to a fresh Debian instance on Amazon Web Services, I am forced to identify all the dependencies that are required to get the app running. Here is the code for the Shiny app I just showed you. The first step to packaging this app is to make sure that all of the libraries that are utilized are available as a Guix package. You would do that by running Guix package search and search for the library. What I found is that all but pool are available, and I had to package pool myself. You can look at the Guix package and our library video to get the details on how that was done. To summarize, once you search for a library, if it's found, it will be prepended with R. So the Shiny library will be r-shiny. All the packaged libraries are lowercase, so the DBI will be r-dbi. Pool is not available in the main Guix repository, but it is now available on the Lab Solutions channel. So you can modify your channels.scm to include Lab Solutions, do a Guix pull, and then you will find our pool. I had to make 2 changes to the app to get this running on Amazon Web Services. First, the driver name has changed from rPostgres to rPostgresQL, probably a result of a version change. You only need to worry about this if you're using Postgres. Then at the end of the app, previously I returned a Shiny app object. In this particular script, the user interface and the server are defined in one file. To make this work on Amazon Web Services, I have to define an app object so that I can then use the method runApp, pass it the app object, and this gives me the opportunity to define the host and the port that I want to use. If I don't do this, our script will use localhost 127001 and it will generate a random 4-integer port number. On Amazon, I need to use the placeholder IP address 0000 and I need to define a static port. I just randomly select 3300. Then on Amazon, I will have to open that port. Here is my packaging recipe. So I start with a template generated by Guix Hall. I talk about Hall in the video Guix packaging some database functionality. I then need to supplement what Hall provides with additional use module statements, and I figure out what those are by Guix package install from file, and I install this file, this Guix SCM recipe file, and I get an error. So for example, the error might be can't find our pool. So I know that I need to use module our pool. Most or all of the R libraries are in new packages CRAN, so I need to include that. I am going to pull a commit from my GitHub account, and that's what I'm going to use as my source code. When I try that, I will get the error message, did you forget to use module Guix git download? We are working with R code, so we need to use the build system R. We need R. R is an unfortunate name. If you Guix package search for R, you'll come up with hundreds of hits. You can go to the Guix new org package list and find that R is in the statistics.scm package. And so we include new packages statistics. Let's look at the inputs. So again, it's error messages that will help me fill out this section. I start with my libraries. I already know those are required, and then it is error messages that will inform me that I need RDT, and R PostgreSQL provides me with the database driver. Next, let's look at the arguments that will modify the phases. So in this section, you'll see that I'm working with 2 different files, shinyln.sh and my app. We've already seen what the app looks like. Here's my project directory. This is the default layout created by Guix Hall. The two files we're concerned with are app.r and then in the scripts subdirectory shinyln.sh. Many of these make-related files and directories we will not be using. Here is shinyln.sh. It is a bash script that will use the rscript executable to run my app.r. But you can see that I prepend it with some random characters. Here I just use the characters A through H. During the packaging process, I will substitute A through H with the path into the store where app.r is located. Back to our recipe file. So here in the first step of the arguments section, I am using the substitute method to replace that random text A through H with the path into the store where my application will be installed. I obtain that path from this association list. This is a list of key value pairs. One of the keys is out and the value is the path into the store for my application. This is an important value that I use in all four steps. Here I use it directly, and in the remaining three steps I take that value and I assign it to the variable out, and then I use it. Let's look quickly at the four steps. So in step 1, I am taking that text A through H and I am substituting it with the path into the store. I am modifying that file, essentially what I might do with sed, the stream editor, I am now doing with substitute. In the second step, I'm copying the app into that top level directory, the one represented by the variable out. Step 3, I am copying my bash script, which is currently in the subdirectory of my repository, the scripts subdirectory. I'm copying it to the variable out, my path into the store, and I've created a subdirectory bin where I am placing my bash script. And then in the last step, I am putting my bash script on the path. So back to step number 2. So now, once again, we are making use of this out variable, the path into the store, and I am using the Guix command install file. This will copy the file from my repository, the app file, into the top level directory in new store, represented by the variable out. Install file means copy the file and create the directory if it doesn't exist. In step 3, once again, I'm using the path into the directory and I'm creating a new string, which is that path with the subdirectory bin. And then once again, I am installing the file, which is going to create this directory and move my bash file into that directory, copy it into the directory. Then the last step is I'm going to put that bash file on the path. So once again, using out, I'm creating the bin directory. I am modifying the permissions on that file to give the file read execute permission, no write. The store is immutable, so you cannot write to it. And then I wrap program. Let's take a look at wrap program. As mentioned in the Guix manual, you might want to clone the Guix repository. That way you have access to all the source code. I've done that. It's in my projects Guix directory. So now I can search for that wrap program definition and see that it is in utils.scm. So here I am in utils.scm, and I have found the wrap program. Here's the basic pattern. First is the variable. Either it's an environment variable like path, or maybe the Guile load path. Delimiter is either colon or maybe semicolon. Position is prefix or suffix. Do you want to put your directory at the beginning of the path or at the end of the path? And then the directory of interest. For us, it is our path into the store. So the program we are going to wrap is our shiny ln bash script. It is in the bin subdirectory of the path into the store. We want to modify the path variable. Our delimiter is the colon. We want to put our path at the beginning of the path variable, and our path is the evaluation of this expression, the bin dir, which is defined up here. We are ready now to transfer our packaging recipe to Amazon Web Services and try to install our Shiny app. First, I need to pre-configure AWS. I've talked about this before. I am working with a Debian instance. I have a script that will do all the preparation. It will update Debian. It will install the minimal amount of software necessary to get Guix up and running. It will call the script that you can download from the Guix site. This will install the Guix package manager. It is modified so as not to prompt the user. All prompts are automatically answered in the affirmative. So, for example, do you want to install Guix? Yes. Do you want to import the GPG keys of the developers? Yes. It will then install the UTF-8 locales, and it'll set up the Lab Solutions channel. This channel will provide you with r-pool. You could go to GitHub, to the Lab Solutions channel on GitHub, and download r-pool.scm directly and Guix package install from file. But as we develop more and more packages, that will become cumbersome. Better to just use the channel and let Guix do all the work. Then it will do a Guix pull that will make the packages in the main repository as well as Lab Solutions available to you. Now we are on Amazon Web Services. Here is the script that prepared our Debian instance. Here is our packaging recipe. We can look at what is installed, and all we have are the UTF-8 locales. We can look at our channel.scm and see that we are set up and ready to pull from the Lab Solutions channel. So let's try to install. While this is running, let me talk about the source origin in the recipe file. I glossed over that. I'm using the method getFetch, and so I need to provide my GitHub URL, the commit that I am interested in, and then I use Guix hash to calculate the SHA-256. For Guix hash to work, the local directory has to be the same as the remote repository. There is a command line switch for Guix -x that will allow you to ignore all Git related files and directories on the local repository. That is helpful, but there are other reasons why you might have content locally that isn't present in the remote repository. For example, you might use a project template software that creates directories you don't use. For example, a doc directory or a tests directory. Maybe you haven't developed your tests yet and the test directory is empty. It will not be propagated to the remote repository, but locally it will contribute to the hash and give you the wrong hash. Also, if you're using new make, most likely your git ignore file is telling Git to ignore the files and directories associated with new make. Those will be present locally, but not in the remote repository. So you will need to put in effort to synchronize your local and remote repository. If you do use the wrong hash, you will get an error message that will inform you of the correct hash, and you can edit your recipe file. That is what I've done here. My first run errored out. I edited the recipe file, and this is the second run with the correct hash. Let's source our profile, and now we can try to run ShinyLN. And so it looks like it is running on the host using the placeholder IP address and my requested 3300 port. So now let's take a look and see if we can open a browser and see our app. On Amazon Web Service, we go into our instances. Here is the instance that we are working with and the transient IP. So I can open this address now, but before I do that, I need to make port 3300 accessible. So I go into the Security tab and I modify the security group, edit the inbound rules, add a rule, port 3300, open to the world, save. Now I go back to my instances. Here's the instance we are using. I can open that address now. So the site is not secure, so I need to remove the S and look at port 3300. So here is my Shiny app. So I can modify the threshold, generate different hit counts, and when I'm happy with the results, I can create a hit list. So this graphic is being generated on Amazon Web Services, pulling data from a database on elephantsql.com, a PostgreSQL database. Let's look in our directory in the store. So here are the files that we have loaded into the store. Here is our executable file. Here is our app. This is the value of out. So when we were working with our recipe file, the value assigned to out is this path into the store in which all our files are. Let's take a look at Shiny LH, this file right here. Let's also look at Shiny LN Real. Let's start with Shiny LN Real. Here is the contents of Shiny LN Real. It is the real Shiny LN.sh that I originally wrote, only now bin bash has been replaced with the bin bash that is present in new store. Guix takes care of this for me. And also notice that in my original Shiny LN, I had A through H /appr. A through H has now been substituted with the path into the store of the appr. You can see it up here. When I type Shiny LN.sh at the terminal prompt, this is the program that I am launching. So again, I'm using the bin bash in the store. I'm modifying the path variable, adding the Shiny LN directory to the path as a prefix, and then I'm executing Shiny LN Real, passing any arguments that were passed into the program. In this case, there are none. So that is how Shiny LN is launched. So we have successfully installed a bash script into our store. That script will launch a Shiny server and load an app. That is useful as a utility app. Maybe you're using it to hack an algorithm or a visualization. If your workflow is such that you invoke the app, use it, and shut it down infrequently, maybe once a week, once a month, then this will be useful. But if you're trying to, for example, augment the functionality of LIMS Nucleus, you could do that with many different Shiny apps. In this case, you'd want to run many apps but launch only a single server. Up here, you're launching an instance of the server every time you run the script. Next time we'll talk about how to run many apps on a single server. If you have questions as to the suitability of LIMS Nucleus for your process, contact us at info@labsolutions.com.